Today we are going to study the part 2 of chemical reaction chapter. In this chapter we are going to study how the word equation is converted into formula equation and how that formula or unbalanced equation is balanced. Everything we are going to study about it. Balancing of chemical reaction by heat and trial method, and we are studying this part 2 on the basis of class 9 and class 10 level. Okay, before studying the word equation, formula equation or balancing of equation, we need to have knowledge, good knowledge about some of the topics here at our level. For example, we need to have knowledge about the name of element from 1 to 20 and their symbol and their valency. I hope you everybody have remembered it. We must have the concept regarding the diatomic element. I have made my previous one video is there related to the diatomic element. Those who have any problem regarding that, you can see and observe that video. Diatomic element, there are 7 diatomic element: hydrogen, oxygen, nitrogen, chlorine, fluorine, iodine and bromine. Okay, whenever they are coming in the reactant or products, in a single, suppose there is hydrogen plus chlorine, it is giving hydrogen chloride, then the symbol for hydrogen we have to write H2, because these are diatomic element. Why we are writing 2 2? You can see my previous video regarding diatomic element. Next, some of the compounds formula we must have knowledge about it. Sulfuric acid, that is H2SO4. Carbon monoxide, that is CO. Carbon dioxide, CO2. Lime water, it is CaOH whole 2. Limestone, CaCO3. Quicklime, CaO. Sulfuric acid, again here H2SO4. Nitric acid, HNO3. Ammonia, NH3. Silica, SiO2. At least these compounds formula we must have remembered before changing the before getting idea about changing the word equation into formula equation. Okay, next, some radicals knowledge we should have. Here are some formula for our level. At least this formula we must know and their valency. So oxide, actually oxide symbol is O minus minus, but here when we are using the in a word equation, if there is suppose written sodium oxide, then what is the formula for that sodium oxide? If we have to change this word into formula, then we have to use the symbol of oxide. Here we have to use O while crisscrossing. Okay, we should not have to use O minus minus. So for crisscross point of view, what formula we are going to use for the different radical and what are their valency, I have written here. Okay, for chloride it is Cl, valency 1. Sulfide, symbol is S and valency 2. Chlorate, ClO3, valency 1. Nitrate, NO3, valency 1. Carbonate, CO3, valency 2. Bicarbonate, SCO3, valency 1 it is. Similarly, sulfate, SO4, valency 2. Phosphate, PO4, valency 3. Silicate, SiO3, valency 2. Okay. If you can memorize it, or you can use some tricks also is here. Wherever ATE is written, ATE, see, observe this ATE, every ATE, wherever there is ATE, there is oxygen 3 in most of the cases. ATE, suppose here is chlorate, here it is coming from chlorine, then chlorine Cl is here and ATE is here, so oxygen is 3 here. I hope what I want to say you are understanding. Just it is a simple logic to understand or memorize. Okay, nitrate, nitrate is coming from nitrogen, so N is here and AT is here, so oxygen is 3 here, NO 3. Similarly, carbonate, it has come from carbon is here, AT is here, then O3. Okay, wherever AT is there you can, and AT represents O3, so it has also 3 carbon. But in these two sulfate, here there is ATE, sulfate, S is here, so S is here, and 80 is here, but oxygen is 4 here. Phosphate also oxygen is 4 here. Then this you need to remember like this is coming sp is slightly greater post sp, so put one more oxygen there. S, not O3 but O4. P, not O3, O4 it is. And remember there valency silicate, it has come from silicon, so it's Si for silicon and O3, ATE there, ATE is there, then oxygen is 3 there. I hope you are understanding, but anyhow you have to memorize this thing, then we can have a better uh, performance while converting the word equation into formula equation, and balancing can be done easily. I hope you are understanding this. Please have a screenshot of this because I am going to rub this. And peroxide, its symbol is O2 and its valency is 2. Formula equation, and also we are going to balance that equation. Let us start some examples here. Suppose there is example number 1, hydrogen plus chlorine, it is giving hydrogen chloride. Hydrogen plus chlorine, it is uh, forming hydrogen chloride. Okay, then last time I said that while writing the symbol or formula of this is hydrogen, it is a diatomic element. We cannot write only H here, we have to write H2 here because it is a diatomic element. Similarly, chlorine is here, chlorine is also diatomic, so we have to write here Cl2. Arrow is here. Now hydrogen chloride, we don't know the formula of hydrogen chloride suppose, then we have to find out this formula, molecular formula, by crisscross method. Here are hydrogen and chlorine. Okay, and one more thing I would like to add here, while doing crisscross, if it is a diatomic element also, we have to use the atomic symbol only. Hydrogen, we should not have to use H2 while doing crisscross. Okay, we have to write H and its valency is 1. For chlorine, chloride also Cl and valency is 1. When we do crisscross, that is HCl. If we do not know the molecular formula of any compound, then we have to do the crisscross, then we have to write here that is HCl. Okay, this upper one, this is the chemical equation, it is written in the form of word, so it is called word equation. This upper one is called word equation. This down one, since their formula are written here and we have shown the chemical equation, this is called formula equation. This is called formula equation. And one more thing I would like to add here, that is here, let us see how many atoms of different reactants and here how many atoms of different products are there. They are balanced or not, let us observe. Here is 2 atoms of hydrogen, but here only 1 hydrogen atom. Here 2 chlorine atom, here only 1 chlorine atom. It means this equation is not balanced. Balanced means what? The number of atoms on the reactant side and number of atoms on the product side should be equal. Then that is called balanced chemical reaction. But when we observe this, here 2 hydrogen atom, 1 hydrogen atom, 2 chlorine atom, 1 chlorine atom. This is not balanced reaction. So this type of formula equation can also be called unbalanced chemical equation. Unbalanced chemical equation. Okay. Now or it can also equation. This can be also called as a skeletal chemical equation. Now we have to balance this. Okay, let us see how to balance. Okay, let it be like this. Now we have to, for balancing the chemical reaction, we are using the heat and trial method. Okay, in this heat and trial method we have to use the different number. Okay, and while keeping the number to balance these atom and these atom, reactant, the atoms on reactant side and atoms on product side, we have to keep the number in front of the molecule. We do not have to keep, or we cannot number front of the reactant or product. Okay, let us see how to balance this. Let us write this again. Cl2, it is coming as Cl. We have to move from left side. Okay, we have to move from left side, and if hydrogen or oxygen is coming, we should not balance it at first. We have to balance the hydrogen and oxygen at last. Okay, so atoms we have to balance. Let us see. That hydrogen, leave it. Chlorine is here. Chlorine, how many chlorine is here? 2 atoms of chlorine. So on product side there should be 2 atoms of chlorine. Then we can make here chlorine 2. No, this is wrong. Okay, always we have to keep the number in front of the molecule. So we have to keep here 2. This 2 is for hydrogen also, and this 2 is for chlorine also. Then chlorine atom become 2. Now let us see hydrogen, because only hydrogen is present at last. Then hydrogen is 2 here, and this hydrogen is also 2 here. Then now these atoms on the reactant side and atoms on the product side are equal. So this reaction is called balanced chemical reaction or balanced chemical equation, we can say. It is balanced chemical equation. Okay, now how to read this reaction? Let us see. One molecule of, here no numbers are there, then that represents 1. Okay, one molecule of hydrogen react with one molecule of chlorine to produce 2 molecule of hydrogen chloride. Okay, this is a balanced chemical reaction. Let us see some other example. Okay, this is the word equation. Now let us convert this word equation into formula equation. Then first we need to have knowledge about the its formula, potassium chlorate. Suppose we have not remembered it, then let us do crisscross. Potassium chlorate, then potassium symbol is K, chlorate formula is ClO3. Just now in my previous photo there is formula for chlorate, you can see there. Potassium valency is 1, chlorate valency is also 1. Okay, then let us do crisscross. It is coming what? KClO3. K, this valency is coming here 1, so we do not have to write 1. This valency is coming here, then we do not have to write 1. If it is more than 1, then we have to indicate that. Okay, it became KClO3. I hope you have studied the crisscross. Okay, now this KClO3, it is changing into potassium chloride. Suppose we do not know the formula for potassium chloride, then let us do the crisscross. Potassium symbol is K, valency 1, chloride symbol is Cl, valency 1, crisscross, it became KCl. So right here KCl. Now here is oxygen. Oxygen, we know that it is a diatomic element. Then if it is a diatomic element, we have to write oxygen symbol O2. Okay, now let us balance it. This equation is the formula equation. Okay, let us see it is balanced or not. Let us see here. How many K here? 1. K is 1 here. And while balancing, we have to see every atoms individually. Not we have to see KClO3 at once. One atoms we have to see individually. Either its number on the reactant side and product side are equal or not. Here K is 1. Here K is 1. Cl is 1. Cl is 1. O is how many? 3 it is. If the number is at back, this is for this atom only, not for this. Okay. Oxygen is 3 here, then oxygen is 2 here, 2 here. Then how to balance it? Can we add one atom of oxygen here? No, we cannot do like this. Okay, let us see how now it will be balanced? If here is 3, here is 2, if it is not being directly balanced, then let us uh, make the LCM of this. 3 and 2 LCM is how much? It is coming 6. Now our target is come 2. Now our target is to make this oxygen on both side 6. Okay, then this oxygen is 3 here. If we add here 3, then 3 and 3 6 it is becoming. No, this is a very blunder mistake. We should not do like this. This number and this number is multiplied, not added. Okay, so here is 3, then we have to make this 6, then we have to keep here 2, so that 3 to the 6 oxygen became. Now this side also we have to make this oxygen 6, then here we have to keep here 3, so that 3 to the 6 it is becoming. But when we kept here 2, the this potassium K and Cl is disturbed, because already earlier it was one this side, one this side, Cl1 Cl1, it was balanced. But we have kept here 2, then its number has changed, it became 2, so we have to make here 2, Cl also 2 here, then Cl also became 2. Now every atoms on reactant and product sides are equal. Now it has become balanced chemical equation. I hope you are understanding how the reactions are balanced. This is the word equation. Let us change it first into the formula equation. Then the formula for ammonia we have remembered, that is NH3. Okay. Sulfuric acid formula I have written on the board earlier. You have remembered that H2SO4. It is forming here ammonium sulfate. We do not know the formula for ammonium sulfate. Then first we need ammonium symbol is NH4 plus. I have not included this, but you remember ammonium symbol is NH4. Its valency is 1. Sulfate symbol is SO4 and its valency is 2. Okay. Now you do the crisscross. When you do the crisscross, it is coming, this 2 is coming to this hole, so NH4, this hole 2, and this 1 is coming, then 1 does not matter, so we can directly write SO4. The symbol for molecular formula of ammonium sulfate is NH4 whole 2 SO4. Okay, now this has become the formula equation. And once it has become the formula equation, now we have to balance it. Let us balance. Let us see whether it is balanced or not. Let us move from the left to right. First it is nitrogen is here. Here nitrogen 1. Here no other nitrogen. This side how many nitrogen? 1 here, but this whole is here 2. Then this 2 is for nitrogen also. Then here how many nitrogen became? 2 this side, product side, but only 1 in the reactant side. So let us make it 2. Nitrogen became 2. Leave hydrogen. We will do hydrogen at last. Let us move. Again hydrogen came. Leave hydrogen. Now sulfur came. Sulfur is how many this side? 1. Okay. This 4 is for oxygen only. 2 is for hydrogen only. Sulfur is how many? 1 here. This side sulfur is how many? Here only 1. Okay, this is balanced. Now let us see hydrogen and oxygen now, because no other atoms are left now. Only hydrogen and oxygen is left to balance. Let us balance anyone. Hydrogen. Let's see here. How many hydrogen here? 2 3 are 6. Here is 6 hydrogen. Here how many hydrogen? 2. Total hydrogen on the reactant how many it became? It became 8. So our target is to make the hydrogen 8 on the product side. Let us see. This hydrogen is 4 here and total it is 2 here. Then this number and this number is multiplied. If it is multiplied, hydrogen becomes 4 to the 8. Okay. Already hydrogen is 8 here. So 8 and 8 balance it is. We do not have to keep any number. Similarly, oxygen, let us see, hydrogen is balanced. Now oxygen how many here? 4 on the reactant side, and how many oxygen here? Here also 4. So it is already balanced. Now this reaction is already balanced. This is called balanced chemical equation. In this way we can this suppose this question is given in the exam, balance this reaction. Then first we need to convert this reaction into the formula equation. Here is sodium hydroxide. Sodium of, let us do crisscross. Sodium valence is 1. Hydroxide. You remember this. I have not included in my previous photo. Remember this. Okay. This formula is OH. Its valency is 1. Do crisscross. It is coming NaOH. Okay. This is NaOH is the formula for sodium hydroxide. And nitric acid you have to remember, that is HNO3. Okay. Now it is forming sodium nitrate. Then sodium, it is valency 1, nitrate valency 1. It is coming NaNO3, and here is water, that is H2O. Okay. Let us see this is balanced or not. Let us move from left. It is Na here, 1 Na, here 1 Na, balance. Oxygen, hydrogen, leave it. Hydrogen leave. Nitrogen here 1, nitrogen here 1, already balanced. Now let us balance hydrogen and oxygen. Oxygen, let us see, 1 oxygen and 3 oxygen, total 4 oxygen became. Here 3 oxygen and 1 oxygen, total 4 oxygen. This side also became. Let us see hydrogen. Hydrogen 1 here, hydrogen 1 here, 2 hydrogen, already here 2 hydrogen. This reaction is already balanced reaction. Okay, directly balance. This can be the example of. Let us balance this reaction. Aluminium symbol is Al, oxygen symbol is O2. Formula is O2 because it is a diatomic element. Aluminium oxide, Al valency 3, oxide valency 2. It is when we do crisscross, it is coming Al2O3. Okay, Al2O3 we have written here. Now let us balance. Suppose when we move from left to right, aluminium is coming first. So aluminium is how many atom? 1 atom. And on product side how many? 2 atom it is. Let us make here 2. Okay, aluminium is balanced. Now let us see oxygen. Oxygen is 2 atom here, but oxygen is 3 atom here. Then how to balance this oxygen? We have to take this LCM. Here 2, here 3, then 2 into 3. LCM becomes 6. We have to make this oxygen 6 on the both side. Then while making this oxygen 6, we have to put here 3, so that 3 to the 6 it became. But here how to make this oxygen 6? We have to put here number 2 here. So then 2 3 the 6 it become. But when we are putting here 2, the aluminum is being disturbed. Now this aluminum become how many? 2 to the 4. But here aluminum how many? It is 2 only. Then we have to make it 4. So this method is called hit and try. Hit and try. At first we have heated here 2. Now we have to heat 4 here to balance it. Okay. In this way we can balance the chemical. That is the type of chemical reaction on the basis of heat released or heat absorbed. There are two. Okay. What is the difference between them and what is the concept regarding this? Let us try to understand. Endothermic reaction, this is such type of reaction. If we provide heat, then that reaction is occurring, but if we are not providing heat, that reaction is not occurring. It means to conduct the reaction or to process the reaction, we have to give heat to that reaction. The reaction that require heat, that is called endothermic reaction. Okay, in reactant we have to apply some heat, then only that reactant will change into product. We can see some example here. Suppose calcium carbonate is there. If we do not heat it, it will not change into other component. But if we give here heat, it will change into calcium oxide and carbon dioxide. Okay. Similarly, there are some reactions. Simply when we put the reactants together, reaction starts, and and when the reaction starts, that reaction will produce heat. For example, in a beaker, if we put some acid over there, if we put some acid like hydrochloric acid over there, then it will change into zinc chloride and hydrogen. And when it will change into, when this reaction is occurring, automatically that beaker become heated. It means that when this reaction is occurring, they are producing some heat. Okay, that type of reaction is called exothermic reaction. When the reactants are changing into product, heat is produced. Okay, this is called exothermic reaction. Okay, I hope you understood what is endothermic reaction and what is exothermic reaction, and you have understood the changing of word equation into formula equation, and how to balance the chemical reaction. I hope you have understood this, but still, and you try to solve the different problem that is given in your book. If still, if you have any problem, please comment. I will certainly support you. Thank you very much. Best of luck.